All right, cool. So thank you for coming. This is my talk about our in-house CD tool that we built called Hammond. I don't actually have a slide on the etymology of Hammond, but basically our company's got a weird things for dinosaurs, like our main product's called Raptor. Our documentation store is called Jurassic Park, and like the guy that built Jurassic Park, as you probably most of you know because it's a room full of nerds, it's called John Hammond. So we called our deployment tool Hammond. And obviously there's a bunch of internal memes about like Richard Hammond and crashes, and you know, there's bants happen. Cool. So yeah, this is me, I'm a staff engineer. I also lead the FundApps developer experience team. There's a QR code for my LinkedIn there if you want to like read a bunch of crap that I write on the internet, you know, welcome to. So, so who are FundApps? I'm not part of our biz dev team, so I just copied some stuff from our website. But we help investment managers harness the power of community and technology to automate regulatory compliance. So we make sure financial institutions have the capability to be good boys and girls when they're, you know, doing business. We were the first compliance as a service company. We've been around for about 10 years. We're a B Corp. Our people operations team are really proud of our B Corp credentials. I think they're in like the 90-something%. Like, I think they're aiming for like perfect B Corp score. And it's a pretty cool place to work. Like, you know, I've been there a couple of years. I'm pretty happy, you know, good work-life balance. We get to work on fun stuff. Yeah. So, DevX. Does anyone know what DevX is? Anyone heard of DevX? So, when I started, we asked for a platform team. Platform teams have kind of got like a bit of a history. Some people have kind of not liked platform teams. A DevX team is basically a platform team, but it's a trendy, fun new way. So DevX is developer experience. So we probably do a little bit more like UX-y, like actually trying to make sure that our developers can do their stuff and are also happy with their tooling rather than just like ruling with an iron fist kind of stuff. So yeah, we're made up of two people that literally dream in Terraform and a developer for the sake of balance. Poor Samuel. But we will contribute quite a lot to other code bases, like, you know, we'll get our hands dirty with Python and Node.js and .NET and all kinds of stuff. And that, I think, has been the key to our success as a team, is the fact that we don't just stay in our lane. And yeah, we don't do the gatekeeping thing. Like, it's very rare we set like rules and policies around what our product teams can and can't do with their infrastructure. We tend to try and just like guide them towards doing nice things, which is hard, but you know, it causes way less friction. I think people are generally happier working like that. So anyway, enough babbling. Here's some things that I hope you'll take away from this. Obviously, I'm going to talk about building a CD tool. And spoiler alert, probably for most people, it's not a good idea, because in most cases, the off-the-shelf products will probably do what you need to do. But there's a bunch of stuff we learned from this that actually might be useful in other contexts. So that includes running lots of highly parallelized workflows for like very low compute overhead, like really cheap AWS bill. Little bit of knowledge about how to not build step functions, because it can be hard.
I've built a lot of step functions.
Have you tested them?
Badly.
So sorry, the comment was, I've built a lot of step functions and testing has been badly. So yeah, we'll talk about that. And yeah, maybe a little bit of inspiration for building some usable tooling for your other operational tasks, and maybe about how event-driven processes can improve some of the work you're doing. Spoiler alert, this is a massive advert for EventBridge, because it's awesome. So to understand why we did this absolutely mad thing of building something from scratch, I probably need to give you some context. So lead time. Does anyone think fast lead time is something you don't want? Cool. So like, it's kind of easy to think like, oh, if I change some code, as long as it eventually gets deployed, it's kind of fine. It's not, and the reason it's not is because it can be really context switchy. So like if you deploy something and you introduce a bug, and that bug doesn't get caught by your test suite, and that goes out to production like, I don't know, 4 or 5 hours later, and you've already gone and picked up your next ticket, you then have to context switch back to your first ticket to fix your bug. Like, there's no state of flow. There's no state of flow. Like, it messes up your workflow. It messes up the workflow of the people you collaborate with. This is all like, if anyone's ever read anything about like Dora metrics or what's it called, the Phoenix project, this is the kind of stuff that's all about. And that's kind of the point of DevOps, I guess, is to try and like optimize that flow so that the stuff our developers are doing gets value in front of our clients as quickly as they can. So what do developers want? Shipped applications. When do they want them? Yesterday. Welcome to the meme show. So yeah, I've kind of mentioned this already. Building a CD tool from scratch is insane. Like, you know, there are a bunch of commercial tools out there. You really, before you do something like this, need to make sure you need to do it. Because ultimately, when I'm writing a CD tool, I'm not writing stuff that directly benefits our clients. Like, there's an opportunity cost there. But we did look at all of the commercial offerings and we couldn't fix our problems. So here's a little diagram of like basic world. I'm a developer. I want to ship some code. So I raise a PR. My PR goes into like our test pipeline, and there's like a static test environment. This is like the olden days when people had servers, like, you know, that they patched by hand or maybe ran Puppet or Ansible. So you had kind of limited amounts. So like this is a constraint, waiting for that environment to be free. And then you've got to deploy it, you've got to run your tests, and if everything's cool, you might start to then go and get a deployment out. Now, in this world, one of the advantages you had is that your local environment probably looked quite similar to what one of those servers looked like. So the probability of your test passing, if you've run them all locally, should be pretty solid. Should be. So for us, like, this is kind of a snapshot of roughly what our company looked like some years ago. So we've got like, what, 10 developers there, like 20 odd clients, something like that. Not real data, just representative. And I'll come on to show you why that is relevant information. So our 10 developers, they're working in a mono repo, big old Windows application, big Windows application, like 600 meg git repo, silly, massive .NET application. I've used the old .NET logo because it's an old piece of software. We do keep our stuff up to date. You know, that's just there for the bants. But yeah, so they're contributing to that thing. There's a higher probability when they push and raise a PR, the tests are going to pass and it's going to go out. So they're probably getting like a couple of production deployments out a day, and it's kind of fine. You know, it's kind of working. And then we have this thing. So this, like I said, big old Windows application. And one of the things part of our product does is when somebody needs to report something to a regulator, we go and trigger Rich's PTSD by talking about generating documents. So effectively, we'll grab a bunch of client data. For some clients, that's terabytes. And we'll go do a bunch of stuff and generate a very specific document that a regulator wants sent over in like a docx or a PDF or whatever other legacy stuff these financial institutions are kind of used to receiving from compliance teams that do stuff manually. So that's a really memory intensive application. Now, obviously we'd love to just have like, oh, another thing actually, like all of our clients kind of want their own kind of like little walled garden. Like, you know, they don't want any cross tool. They don't have their own database, stuff like that. It's not like Gmail, where all of our Gmail accounts live on the same massive SQL cluster or whatever. It's all a bit more segmented. So they all have their own deployed version of our application. So what this means is to make sure all of them can run a document generation process, we need to go, all right, we're going to split you up into these web boxes and we're going to allocate X amount of you to each. The chances of two of them running one of those processes at the same time, pretty unlikely, so that's good. But there's a problem with this. And the problem is that IIS is rubbish. So yeah, trouble with IIS is that you can't. Anyone ever like hot reloaded an HA proxy config or an Nginx config? It's easy, right? It takes like nanoseconds. It's just like either your config works or it doesn't. You can deploy your application in the background, systemd, everything's happy. IIS is rubbish. You can't do that. So you have to use a mutex. And if you don't know what a mutex is, if I give you that, none of the rest of you can drink a beer all the time he's holding that. You've got to wait until he's done. Okay, now you can pass it to Rich, and Rich can drink his beer. Right, see how this is going to be really slow for everyone to drink their beer. Right, Rich, can I have my ball back, please? Well, the entire pipeline dies, probably. So yeah, so that's a problem. So we go back, and it means that rather than that deployment taking a couple of minutes, it now takes X amount of minutes multiplied by however many tenants we've got on one of those boxes. So you start to see how the more work our biz dev team do, the slower our deployments get. The more engineers we hire, the slower our deployments get because we start pushing more deployments through. So yeah, it gets pretty hairy. But that's not all, because we're also actually using Octopus to deploy to the test environment in order to get a PR shipped in the first place. So it's even worse. And yeah, you end up with a queue, something like this. So you're going to see like this poor PR sitting there behind like clients 1, 2, and 3 waiting to go out. So anyway, I joined a couple of years ago, and just after I joined, we started bringing adjacent products into our product suite. And we started doing stuff with serverless because, well, we didn't want to keep shipping stuff to Windows boxes. And in some ways, that was a little bit better because we'd build and deploy to a testing environment using GitHub Actions. We'd just run serverless deploy on the GitHub action. We'd run the test. Everything's good. Bish, bash, bosh. But then we're still using Octopus to deploy to places. So now we've gone from all of those clients, which are a constraint. We've gone from all of those deployments, which are a constraint because of all of the engineers that we're now starting to hire. And now we've basically doubled the amount of things we're trying to push through that Octopus pipeline. So it's getting really, really bad. And we've got plans to just start doing more serverless things. So it's going to get worse. So a little bit of a recap. Serverless deployments were not constrained by an IIS mutex, but they still get stuck in an Octopus queue. This is a slightly frustrating thing with Octopus. Like we kind of could have brought up like more instances of Octopus and just isolated the queues and carried on using Octopus, but it just kind of felt like we were kicking the can down the road. Also, Octopus has either an awful Terraform provider or an awful API, which presents itself as an awful Terraform provider, one of the two. And we do a lot in Terraform, like everything we can Terraform, we Terraform basically. So we kind of wanted to get rid anyway. So yeah, kind of hypothetically, any centralized compute resource that we used for running deployments at this kind of scale was eventually going to become the constraint. And it was getting in the way of our technical strategy. As I said, we wanted to do more serverless stuff. We wanted to be moving everything so that each of our tenants, each of our clients had their own AWS account. And, you know, the deployment pipeline was ruining everybody's fun. So there we go. More clients equals more load, more developers, more load, more applications, more load. So constraints on constraints on constraints. So really to drive the point home, we didn't want to have to build a tool from scratch, but serverless's commercial offering was probably the best looking option out there, but it didn't support .NET. So, you know, that wasn't going to happen. Harness.io kind of had some interesting features, but it was for their beta product and they didn't support a bunch of things that we wanted, and we could wait for them to build beta features, but how long are you going to wait? Argo CD is amazing. Like, lots of the inspiration for what we did with Hammond came from Argo CD, like pool-based deployments, completely decentralizing the compute that's actually running the deployment task was like that was where we wanted to go. GoCD is very powerful. It's quite complex. There's a lot of plugins. It also felt like we'd have to run some servers, and I hate running servers. Like, yeah, like, do you know what I mean? I might as well just go back to using Jenkins. Like, not going to happen. So yeah, pros and cons of building versus buying. There was the months of engineering time. Potentially a massive support overhead. It's actually not a huge support overhead. It's pretty cool. There was also a bit of like, is this even going to work? Like, you two are mad. Like, here's enough rope to hang yourself. Like, yeah, you know, go do it. But like, but are you sure? It obviously worked. It was fine. But yeah, you know, there's some advantages to doing stuff like this if you have to, and that's that our team can respond really quickly to the needs of the business. Like, you know, if we need to add a new feature to Hammond, or we need like find a bug or something like that, we don't have like a bunch of other customers that we've got to like prioritize. We just do it. And it's also something that fits the needs of the business exactly. You know, as I mentioned with GoCD, like GoCD is crazy powerful. You can do a bunch of stuff. Lots of these deployment tools are. But then you've got to learn the deployment tool. It's like, it's just one form of complexity for another. And despite its scale, our deployment process is actually pretty simple. So I've kind of touched on this. This was our new tenancy model. You can see we've got all of our clients here, including Sunglasses Guy. They all have their own AWS account. Don't know what more to tell you. They have AWS accounts. And yeah, so there was stuff we wanted to do differently. So we didn't want any of the queuing problems. We didn't want any of that centralized compute constraint. We didn't want any noisy neighboring. So kind of the point of doing the AWS account per tenant was because the old Windows Server model was like, you know, if you had a client that was doing a really expensive thing, that could affect the performance of everybody else on that box. And that's why we have an AWS account per tenant. They have their own service limits. You know, they have, it's really easy to see the billing for each individual client, see how much compute they're chewing up. And it's also really good for our biz dev team. They can just say, hey, you get your own AWS account. Like, they don't have to have any complicated security conversations. They're like, it's in a box. There you go. So yeah, so we didn't want any noisy neighboring. We wanted to maintain that pattern. We didn't want to waste pointless compute. I say have ambitions. I think we're basically there with going net zero this year. So yeah, you know, not burning trees pointlessly. Oh, look, the TV died. And it's back. And yeah, we also wanted to do the pool-based deployment thing a la Argo CD. So the next thing we did is we went and spoke to some of our product teams, and these were all the things they said they wanted. Faster horses, anybody? I'm being facetious. These are all actually quite sensible. So they wanted to be able to redeploy a particular environment type. So we have like customer production environments, customer staging environments, customer performance. We have internal testing environments. We have remote developer environments, which is basically an extension of your laptop. There's a bunch of different types. So that was really important. They also wanted to be able to block particular deployments for a development environment. So if you're working on regulatory filing, you don't want my automated deployment deploying over the thing that you've deployed to your dev environment because you're doing work. So that was a thing. They wanted to be able to manually deploy, fine. The approach to promoting artifacts, we were actually happy with, so we kept that. We wanted to be able to do rollbacks. That didn't get implemented because it's quick enough to just roll forward. You just deploy the old version over the top of the old one. Like, no need for extra complexity. From a visibility point of view, we wanted to be able to aggregate on version numbers, tenants. We wanted to be able to find out why things broke when they broke. Wanted to be able to see how much stuff was successful, what releases were deployed where. We wanted some more stats like mean, median, blah, blah, blah. And also we wanted to know if a deployment, if we'd sent out a deployment, if it hadn't reported back as successful or failed. And this is kind of a bit of a nuance with the architecture and the way we built things. Like if you were doing like an Octopus or a Go CD thing where you're managing it all from like that one centralized process, you know when it's failed because you are the executor. What I'm about to show you is a bit kind of like fire and forget. Like, here's your thing, off you go, bye. So yeah, we needed to know when stuff we expected to go out hadn't gone out. So here was our thinking. We thought, we've got a bunch of observability and monitoring tools. We use Datadog, which I hate, but whatever. But we'll use Datadog. Like, we've got logs. It's fine. It's fine. That we trigger a deployment when you push an artifact to an S3 bucket. Like I mentioned, I'd be doing a sales pitch for EventBridge. Do you know what happens when you push something to an S3 bucket? You get an EventBridge notification. That also happens when you tag stuff. There's EventBridge notifications going on that you're probably not seeing in massive volumes in all of your AWS accounts. It's great. And yeah, the deployer compute would run in every tenant account on demand. So like only when it actually has work to do rather than just like sitting around being bored waiting for stuff. So here's a diagram of what we thought we were building initially. Looks pretty simple, right? Push an artifact, goes into a bucket. Your test account has a look. It goes, all right, haven't got any tested tags. All right, I'll deploy it, see what happens. And then your test account goes, cool. Everything works. I'll tag it to say that I've tested it and that it works. And then you get another EventBridge event. And then the prod and staging account's like, cool, deployment works. I'll have that. Simple. Except for the fact that we wanted to know when things hadn't reported back as successful or failed. So we needed a register. We needed to work out where we expected things to go. And then we needed to know if they hadn't gone there. So we wrote, I'm going to say little Lambda function. It's the biggest Lambda function in the entire stack. And there's a small handful of them now. Does a bunch of business logic, looks for feature flags in our tenant config file. Some of our clients don't want our regulatory filing service. Some of them don't want another service. It's all variable. Looks at environment types, looks to see if you've turned off deployments for a particular thing for your RDE or whatever. And then you can see from DynamoDB, there's an arrow to EventBridge. That's not a thing. It is now a thing with EventBridge pipes. When we built this, that wasn't a thing. So there's actually that EventBridge gets triggered from the registrator rather than out of the back of DynamoDB, but whatever. And then we go off into our tenant accounts, we go and do our deployment, and then when everything's finished, we write something back to the table. So we've now got visibility of that. So why did we choose EventBridge over SNS? Integrates with a bunch of stuff. There's a bunch of cool data already flowing through the AWS account. I also like the rule-based subscriptions. With SNS, you can have a topic, you can chuck a bunch of stuff at your topic, and you can either subscribe or you can not subscribe. EventBridge is more like having a Gmail filter that forwards everything from your old email address from when Gmail was invite only to your new one, which is just the stuff you care about. So you just filter stuff from Rich and you forward it to your new email address because that's all you really care about. Everything else is just spam. And I will show you some examples of some EventBridge rules later on. But what that means from a general application architecture point of view is that you can start, when you're building out microservices and stuff like that, you can start just pumping messages into EventBridge. And then when your next service comes up that might care about an event, they just write a rule and they just subscribe to it. There's nothing to do. It's a really nice way of decoupling that way of communicating between services. And that's kind of the other thing that we sort of do, is we go and play with shiny new toys and then tell the rest of engineering if they're cool or if they're going to be a massive pain in the ass. So this is the step function workflow that runs in the central Hammond service account. So you tag an S3 object and you enter here. We go and get some stuff from SSM, and I will talk about that when we talk about testing. We transform it because JSON path is annoying. Yes. And then we do our registrator thing. And then what happens is step functions isn't great with like time. You can't just be like, you can't do a sleep for 60 seconds, sleep until this time or something like that particularly well. So like we just spew timestamps out of the registrator and the verifier lambda functions so that the step function kind of knows what it's doing. But yeah, so the verifier, I think you get like an hour for all of your deployments to complete. None of our deployments take an hour, but like it gives you an hour. And like, if nothing's completed within an hour, then your artifact doesn't get promoted. But by the time all of them have like reported back as successful, we step down into here and we go and have a look at our tags and we go, all right, that hasn't been deployed successfully to anything until now. We just did a bunch of FundApps testing environments. They look good. So we'll tag the artifact with a success. And as soon as that artifact gets tagged, we do the same thing again. But this time we boot everything out to customer production environments, and jobs are good. I was talking to someone outside. It's like, you take away the scale, it's not that complicated. Like there's not a huge amount to it. You fire an event, you spin up a container in the other step function that I'll show you later. Hi.
Hi. Maybe I'm looking at it wrong, but what's the line on the verified 30 seconds choice in the middle?
This one?
Yeah.
When does that one fire? Oh, so the question was, what is the line in the middle coming off the end of the verifier? So that would be a scenario. Aha. So that is a scenario where if you've triggered a manual deployment, in the event of a manual deployment, we don't want to promote an artifact because it's just someone like manually booting a thing into their testing environment or whatever. So in that scenario, we just come out the bottom and we go, hey, your thing's deployed, but we're not promoting it. Keeping me on my toes. Okay, so why step functions? I want to preface this by saying that we've done some complicated stuff in step functions that I will show you all later. And it was slow to develop compared to doing that same thing in Python. It was long, but I've never had to merge a dependabot PR for a step function. I've never had Sneak tell me that a library that my step function's using is, going to make our entire company explode. So in terms of like a tool like this, where I just want it to run and for people to use it and for me to not have to do any work, which is basically everything I build, like low work, step functions are kind of great. There's also those diagrams, which are kind of cool. Like a bit easier to do that than to, I suppose there might be tools that can read my Python and produce that kind of diagram. I've not tried, but I'm gonna. It suits long running processes way better than Lambda. I think, is it 15 or 30 minutes, the Lambda timeout? 15. Of course you know. Yeah, in all fairness, I did look exactly at you when I asked the question. And yeah, EventBridge compatibility. I like EventBridge, what can I say? So yeah, MVP, we've built some stuff. We've migrated some services off Octopus. Like everything's working. Deployments are looking good. People wanted a manual deployment tool. I've got gray in my beard and I like Linux. So this, in my head, is perfectly suitable for your manual deployments. Like, chuck it in a bash alias. Like, it's fine. But yeah, it turns out not everybody wants to live in the command line all the time. And And that's cool as well. You know, we're a DevX team. This is what I mean. If we were a platform team,
You just tell them they're wrong.
exactly. If we were a platform team from the audience, we'd just tell them they're wrong. But we're a DevX team, so we do what our developers want us to do.
Even if they're wrong.
Yeah, because they're the users of our product. So like whatever. So yeah, this covers all of those requirements, like rolling back and pushing a release to a single environment or redeploying a particular environment type. So this is what we learned from the MVP. Dynamo writes are not natively supported by EventBridge events. People really like pretty UIs. Datadog was not as effective at replacing a UI as we'd hoped. I mean, like, we didn't have particularly high hopes, but it fell really short of even those. So, yeah. The product we built was, like, reliable, and it was quick. Like, the nuts and bolts were good. Step function testing sucks. I've been on calls with, like, some of the AWS product people about this, and, like, you know, they're trying to do a thing, but I don't know any more about it. But yeah, hopefully it will suck less at some point. And our zero Q mentality actually might be problematic because there's a scenario where things might explode a little bit. So here we go, product maturity. Here's my most favorite mature cartoon character, Eric Cutman. So here's a developer. We're going to call him Will. And on a Monday, Will comes in and he's like, oh, I've got a load of dependable PRs. I'm just going to merge all of them right now. So that's what Will does, and that's cool. Like, it's fine. They will pass the test, whatever. So the first one, pass the test, like gets pretty, just boots itself into a deployment, and it starts running. Serverless deploy executes, and if anyone knows anything about serverless, it's basically CloudFormation, but slightly less disgusting. So yeah, the first one's happy, but the second one that comes in like 3-4 seconds later, that tries to deploy, and what it gets back is an update in progress status from CloudFormation, which means the second deploy fails, and the third, and the fourth. So this is a little bit disheartening. So what do? We build some queues and we build some mutexes because that's not where our problem started. So we did this in the least ghastly way we possibly could. And we basically said, all right, each tenant is going to have a DynamoDB table. In that DynamoDB table, you're going to have the name of every application, and you'll have an event ID for the deployment that has a lock, and you just do a quick mutex. So there's no mutexing, like that's not shared across tenants like it was in the Windows world. It's not shared across applications or anything like that. It very rarely gets used because it turns out that people don't merge too many dependable PRs at once. And by the time they've actually got through other processes, it tends to just kind of be all right. But here we are. So we decided to build this purely in step function. Don't do this. Don't. Here's where we really discovered how painful testing step functions is. I mean, like, look at it. Look at it. Like, everything in this box here, that's just the locking process. Like,
What's the line now? I'm not going to do this.
go on. What's which line? Which line?
No.
Any of them? What's all of them? I wish I could remember. But it has tests and it works, so it's fine. But yeah, like the nuts and bolts of how this works lies in error catching in DynamoDB, in step function. So like right here, you go and acquire a lock. And if you acquire a lock successfully, you go bing, you leave the queue. If you happen to be in the queue, you leave the queue. And if you're not in the queue, you just pass and you come out and you do the deployment and everything's cool. But if you can't get a lock because there isn't a record for the application you're trying to deploy, you initialize a row, you come back, you try and do the same thing, and then you probably get a lock and you come down here. But if not, you come and you get the lock record, you see what's waiting, you do a bunch of stuff, and you just kind of sit and wait until you can get that lock, and you just loop through that process. And yeah, I honestly can't. This was like a couple of days of like just being very frustrated at step functions. Anthony, like the other person in my team, was on holiday. I went on a massive tangent. I'm never going to do it again. But there it is. But yeah, so the reason I kind of wanted to call this out is that a lot of the power of step functions and the way that you can do interesting things with it is in the way you catch and handle errors. Like, I mean, it's a try catch loop. Like, that's it. But yeah. So, testing step functions. Has anybody got any working tests for step functions?
Yeah.
How? What do you do?
There is actually a test framework for it, but it's only about 3 months old.
Okay, so apparently there is now a test framework for step functions, but it's only 3 months old, which means it's no use to me now. Thank you. Okay, so what I ended up doing, because there was no test framework at the time, turns out my slides are lies, but whatever. So I brought up SFN local, which is like a Docker container with a step function thing, and you point your step function at it. You execute the step function, you give it a bunch of mocks, wait for it to finish, because you might have some sleep loops and locking things and all kinds of complex rubbish in there. And then you get the payload of the result. And because I'm a lunatic that can write Python, I decided to do this in Bash with JQ for whatever reason. Like, I think it was one of those things where I was like, this will be easy and won't take 5 minutes, and then just turned out to be way more complicated. But yeah, so I did that. It's still a little bit flaky, but it mostly works. We're using it in some other things. It's kind of fine. Don't ever do this. There's a tool that I saw at FOSDEM, which I've seen demoed with step functions, called trace test. So you turn on X-ray tracing for your step function, you run your step function, you get a bunch of trace data, and you do asserts on what's happened within your trace. It's a much saner way of dealing with this stuff, and it's even got a nice UI. So yeah, don't do that. This is becoming a bit of a theme, isn't it? Like, don't do this, don't do this, don't do this. Okay, so people wanted a UI. Tooling choices. Like, back in the day, Rundeck was kind of a cool thing, but it hasn't really, it didn't seem to be a viable thing for what we wanted. It's another Java one. It's another Java one. It's very plugin heavy. It wasn't really the right thing. We looked at some of the trendier new, like, no-code, low-code UI tools for kind of doing this kind of Opsy work. We looked at one called Retool. It kind of looks all right. Mostly the reason we didn't get it is because their sales team were really salesy, and like our team are really stubborn. So, so yeah, we didn't buy that. And we also had a look at AWS Amplify, and this was kind of one of those scenarios where I wanted to use an AWS product, but they didn't have a really basic thing that I wanted enabled, so I ended up not doing. And that was that you can't log into AWS Amplify Studio with AWS SSO. Again, they might have fixed it, whatever, too late, we're using something else. Yeah. So yeah, we ended up going with a tool called Airplane, which, Rich, catch. Nice. So I will show you Airplane now. I'm going to have to sit down to do this. Okay, so this is a thing that we pay people for, but essentially it's an opinionated enough wrapper around building ops tasks, runbooks, and UIs that even someone that lives in Terraform and Bash and JQ can actually build a UI. So yeah. So yeah, we built this thing. This is our dev account, so expect to see lots of failed deployments pointing at my environment. But yeah, so we can see here a bunch of recent deployments that we've run. We can see what tenants they targeted. We can go and queue a run for their Scalar workspace, their Terraform workspace that relates to this application. Like a common thing that will happen is someone will release something, the infrastructure underneath it won't be up to date, so they need to go run some Terraform in order for their serverless deployment to work. So like this is a pretty commonly used button. We can flip auto deploy on and off. Only for this one we can't because it's a production tenant, so we've disabled it there. We can go look at the currently deployed versions of things for all of our clients. We can like filter by things and whatever. And then we can go do like some manual deployments, and effectively you can replay an entire thing that might have failed before. You can pick an environment type. You could just go with the last one that looked pretty good, or you can pick a version, and then you can pick tenants as well. Pretty basic, but it's what people wanted, so that's what we built. And the reason I wanted to show you the UI is because before we actually went and wrote some JavaScript, we kind of had to just get people to use tasks like this, and we just found that. So I talk about building people nice UIs because it's what they want. That's a little bit facetious. There's more to it than that. If you build a good enough UI that they can just use intuitively because it makes sense, nobody asks you any questions about how your product works, which is really handy. Like, you know, we invested some time in this, and we've probably made that time back by it just kind of working. And yeah, you know, behind the scenes, behind the scenes, I'm not even going to show you. It's basically just Python. It's Python and YAML files. Yeah, you define a task, you point it to a Python file, you deploy it, they run it. It supports OIDC against AWS, which we really like because we banned AWS access keys like a year ago. So if you're coming from a third party, the only way in is via OIDC. And in most cases, you'll actually log in via OIDC, drop an EventBridge event into a central account, which will then fan out. So none of these tools like Airplane or GitHub actually have a direct interaction with any of our tenant accounts. It's all just like, here's a thing I want you to do, go do it. Like no direct access at all. So I've got no idea how long I've been talking for. I feel like this has gone really quickly, but also taken a while. Oh, crikey. 45 minutes, apparently. Nice. So the results. This is how long it takes to deploy a thing. The time between deploying something to FundApps testing and it getting promoted to customer production is like double-digit milliseconds. Like it's barely even measurable. Like deployment finishes, gets promoted. So that means that like if your test pass, once that zip file has been like dumped in an S3 bucket, you're looking at double that before it's in front of a client. That's pretty sick. And these are the slow things where people want to run like database migrations and annoying things like that. Like, you know, whatever, I'll allow it. This is some feedback from the lead of our Raptor engine and rules team, Layer. So like that's kind of the beating heart of everything FundApps do, really. Like that's our main product. And yeah, massive endorsement. So that's really cool.
They were even on vacation when they said that.
Oh, I mean, like, don't believe anybody's Slack status ever, particularly not if they're a team lead. So Windows deploys, bizarrely, also benefited. We haven't finished gutting the Windows estate yet. We're getting there, but like the Octopus thing still exists. But because we're not stacking all of these serverless applications in there, you know, we're at least not making their queue worse. Also, a bunch of the stuff Rich's team did about like pulling those big document generation workflows out of our web boxes enabled us to scale them down, which meant we could deploy more of them, so we could have more mutexes. So we, you know, that's improved as well. Compute utilizations, you know, awesome. We barely use any except when we need to. And yeah, devs are happy. There's the saying, happy wife, happy life, happy devs, happy something else. I don't know. And like, So I did this scale thing at the beginning, right? Where I had like 10 developers and like 20 clients from some years ago. This is real scale. This is real scale. This is us now. I might even be missing some application repos from the middle. That's what Hammond's dealing with. It's fine. Like I say, almost unlimited production deployments today. Like let's say your application takes 5 minutes, so you get 12 an hour. Let's work for 8 hours a day. So it's not unlimited. Like every application can probably deploy 96 times a day to production. If anyone can build me a CI pipeline fast enough that Hammond becomes the bottleneck there, like we're hiring basically. So yeah, talk to me afterwards. So yeah, we've stopped having to do like those big, massive, cumbersome changes. We can just make like a quick change, ship it, it's out, it's done, everyone's happy. We're also not using TeamCity, we're using GitHub Actions. So that's pretty cool. And we got all of these cool reusable patterns out of it. Like I said, you know, we're kind of, DevX can sometimes just be like the proving ground for like a way of doing a thing. And it was very much that for EventBridge with Hammond. So yeah, we do a bunch of this, like fanning out of events to like all of our tenant accounts. Like we do it all over the place. So this example is where we just like bounce some stuff out. If like a config value changes or some metadata changes, like we like to propagate that into a DynamoDB table locally in each of our tenant accounts. This is the EventBridge rule that does that. You can see that we have a local.tenant rule in there. So, you know, the rule is that it only gets sent to the tenant account that it's destined for. And that's like, it's basically what an EventBridge rule looks like. They're really simple. They're really easy. They just kind of work. Also very quick. Here's another example. So is this you or Rory? Okay. So this is one of our other infra engineers writing some JavaScript because, you know, we cross skill. That's cool. But yeah, what he's doing there is just like writing a little operations job for when, if an interaction with one of our third parties doesn't go according to plan, we might sometimes just need to like, you know, pay a little bit of attention to the database. We don't want people logging into databases and doing stuff like that. So like we send an EventBridge event, fires off a Lambda, like job done. No database is harmed. Other stuff we do with EventBridge, we'll run some tasks and sometimes we'll just do a callback. So at the end of a step function, you might fire off an EventBridge event. We'll just go back to the central service account and we'll just be like, cool, we know that thing happened. Recent one was we started building out like a feature flagging thing, whole other topic. But essentially when you flag on a feature flag for the new Auth0 integration, which is our new like, well, how we do authing stuff, it will just go trigger a Lambda, which will import all of the users from like the old auth place. So that's cool. We just fire an EventBridge event into the tenant account and it does the thing. We also have a thing when we provision a new AWS account, which will just write back to a central database, like this is the name of the account, this is the account number, these are all of the tags. And the reason we do that is it's just faster to read from DynamoDB than hit the AWS organizations API every time you need that data. And we also notify Hammond. So in our Terraform microservice baseline repo, we write an object to S3. It's the last thing we write, but that means once you've provisioned the infrastructure for a new service in a new tenant, we chuck an event back at Hammond and Hammond's like, right, cool, I'll go deploy that now because I've got the infrastructure to deploy it on top of. Tips on EventBridge, I'm nearly finished, promise. Forward all your events to CloudWatch logs. Like literally the first rule you should write is that one, because otherwise you will not know if you've written a bad rule or whether you've written a bad IAM policy, and you will waste a bunch of time trying to work it out. Stick to the default event bus. Like Hammond has its own event bus in like every account, and it was just pointless, and I need to just undo that. We don't need it. The permissions model is pretty good if you use this Terraform resource, the AWS CloudWatch event permission. You can attach a resource policy to an event bus, which is a pain in the neck when you have as many Terraform workspaces as we do, because it means whichever Terraform workspace writes last is the one that writes the policy. What that resource enables you to do is just attach a single permission to each event bus without that last right wins race. So it allows you to be a little bit more decoupled about that process. And that's it. I'm done.